Hi, welcome back to my channel Reagent. In this video, I'm going to discuss about molecular electronic configuration in oxygen molecule. As you know that oxygen molecule is formed from a combination of two oxygen atoms. Oxygen atom and another oxygen atom combine to form O2 molecule. When two oxygen atoms combine to form O2 molecule, their respective atomic orbitals also overlap. Their respective wave functions also overlap, right? So when atomic orbitals overlap, there are two kinds of orbitals are formed. Bonding molecular orbitals and anti-bonding molecular orbitals. So these molecular orbitals can be classified as sigma, pi, and delta. So how many types of molecular orbitals, sigma, pi, and delta, so also formed? Now let us go in detail of this. So how to fill the electrons in their respective energy levels and how these atomic orbitals overlap. When two oxygen atoms combine to form O2 molecule, their respective atomic orbitals. What are the atomic orbitals of oxygen atoms? So there are each oxygen atom contain 1s2, 2s2, and 2p4. Since atomic number of oxygen is 8, there are 8 electrons are present. 1s2, 2s2, 2p4. In another oxygen atom also there is 1s2 and 2s2 and 2p4 orbitals also present. So the atomic orbitals having same energy, same phase, they overlap. Means in the sense 1s2 overlap with 1s2, 2s2 overlap with 2s2, and 2p4 overlap with 2p4. As a result, there are two kinds of molecular orbitals are formed. Bonding molecular orbitals are formed, anti-bonding molecular orbitals are formed. Bonding orbitals have lower energy, whereas anti-bonding orbitals have high energy. Anti-bonding orbitals can be indicated with sigma star, pi star, delta star, whereas bonding molecular orbitals only indicated with the sigma, pi, and delta only. When atomic orbitals having same energy, same phase, so overlap, let us say 2s, 2s. So why I'm not taking 1s2 is very close to the nucleus. Let me take the outermost shell 2s and 2s. The 2s of one oxygen atom combined with the 2s of another oxygen atoms, when they overlap each other, there are two kinds of orbitals. Sigma 2s will be formed, sigma star 2s is formed. So as you know that 2s orbital containing two paired electrons each. So and when two molecular orbitals are formed, bonding and anti-bonding, their respective electrons also from 2s will be paired in the ground state and in the excited state. And electrons also redistributed in the ground state. First one electron comes into the 2s sigma, then second electron from other nitrogen atom will form pair up as per the Hund's rule, and the next rest of the electrons will move to anti-bonding orbitals. Then electronic configuration goes sigma 2s2 and star sigma 2s2 is the configuration when 2s overlap. And next, if we move into this 2p orbital, 2p orbital having electrons. How many electrons? There are 4 electrons. So if you fill like this, there 2px is containing paired electrons, 2py, 2pz unpaired. Here also same, 2px is having paired electrons. As you know that 2p orbital divide into 2px, 2py, 2pz. So since 2p, 2p orbitals of both oxygen atoms are overlapping, and molecular orbitals in the ground state are, if you consider 2pz, 2pz that form sigma bond, whereas 2px and 2py will form the pi bond. So here is 2pz, if you take sigma 2pz here, now 2pz, one electron from 2pz and other electron from 2pz, they pair up, and 2px, 2px, and here also they pair up, 6 electrons already over, and there are 2 electrons that move into antibonding orbital pi star, 2px, 2py, pi star orbital having 1 each. There are total number of electrons in 2p4 plus 8 electrons. So 6 will move into the ground state and they will pair up, and rest of the 2 will move into anti-bonding orbitals. In anti-bonding orbitals, pi star 2px, pi star 2py having each 1. So unpaired electrons. Since anti-bonding orbitals having unpaired electrons, oxygen molecule behave like paramagnetic in nature. So O2 molecule having paramagnetic nature because of unpaired electrons in the anti-bonding orbitals. Let us discuss the bond order. Bond order of O2 molecule. So how we calculate the bond order? Bond order can be calculated as bonding electrons minus anti-bonding electrons upon 2. If we want to write bonding order of oxygen molecule, then we must know the bonding electrons and anti-bonding electrons. So if we want to know the bonding electrons, then we should write molecular electronic configuration. So 1s2, sigma 1s2, and star sigma 1s2, and sigma 2s2, star sigma 2s2. Similarly, sigma 2pz2, so sigma star 2pz0, and pi star 2px2, pi star 2py2. So then the number of bonding electrons, how many? 1s2, 2s4, 4 plus 6, 6 plus 4, 10. So bonding electrons in oxygen 10, anti-bonding electrons, how many anti-bonding electrons? Here you see one is sigma star 1s2 and sigma 2s star 4, 4 plus 2, 6 electrons. So bonding electrons are how many? 6. So 10 minus 6 upon 2, and here you get 4 upon 2, you will get 2. Bond order is 2. Oxygen molecule having bond order 2. Between 2 oxygen atom, number of covalent bonds how many? 2. So compared with the nitrogen, oxygen molecule is more reactive because it containing double bond. So by using molecular orbital theory, we explain the properties of molecule like magnetic property and stability. So we can explain by using molecular orbital theory. Thank you.